Okay, so we've just done a survey with two different GPS brand RTK systems. One was a Trimble field level system using the survey plugin, and one was I think it's probably Integra Nordics or GPS Ag, Australian is the Australian name of the guidance system. So the black line, so the operator drove around the boundary with both systems following very closely so we could check the difference. And the master benchmark is here. So, and then we shifted both, we shifted the multiplane coordinate system so that the master benchmarks lined up. The GPS Ag system saved the coordinates in eastings and northings, you can see with this large number here, and using the GPS datum ellipsoid, and then so we shifted the multiplane so that they matched up at the master benchmark, and then we wanted to see the difference at the extremities, and as you can see there is a significant difference at the furthest point away from the master benchmark, which is about 1400 meters, is 21 meters difference in the horizontal. So those lines should overlap perfectly if the coordinate systems matched perfectly. Now the difference is that Trimble field level system uses a local plane coordinate system, which is slightly different to the other coordinate system, which is UTM, eastings and northings type thing. So you can see it's 21 meters difference there. And on this southern edge, it's 17 meters difference. Now, the problem that produces when we try and export when we try and survey with one coordinate system, do a design, and then export back out to load into another GPS system to do the earth moving, is that these differences can end up producing significant differences in what the design should be. On this field, it's quite flat, very flat field. So this 20-meter error, horizontal error, we tested and found. So this is the proposed topography map, and these contour intervals are around 30 millimeters, around 1 inch. So where these contours change, the closest together, that's where we'll end up with the largest error in our design because of that horizontal error. So looking at these contours, the error at these locations could be, it's around 80 millimeters at that location, 80 millimeters here, and about 40 millimeters at this location. The rest of it's going to be less than that. So now we could add a feature into OptiSurface to translate these systems from one to the other, but there's always the risk that we don't know what the exact coordinate system is that they're using, that each system's using. So just be aware of this issue. And the easiest solution is to survey with the same system, same type of system that you wish to do the earthworks with. And then one other comment is that the further we get from the master benchmark, the greater the error. So if you had a small field that was, in here or in around the master benchmark, the error is quite small. You can get away with it a lot easier. So these are 100-meter grid cells, so 300 feet grid cells. So yeah, a field that's 400 by 400, it's not too bad at all. You get away with it. But large fields, it is more significant. And the other thing is, depending on how large your slopes are. If your slopes range from, say, just for argument's sake, a steep slope that's 10%, and then this is, well, at this point, at 20 meters, say there's 20 meters out and it's sloping 10%, then you are going to be 10% of 20 meters, which is 2 meters. You're going to be actually 2 meters out in the vertical with vertical error. So you can see that's going to be a massive amount of error. So this problem is least significant when you've got smaller fields and flatter topographies. It's most significant when you've got larger fields or larger slope differences. Sorry, or larger slopes. And when I say large, I say probably anything above, 0.1 or 0.2. Okay, I hope that's useful. And thanks for watching.